Now let's classify matter according to composition. So we can classify matter according to composition by noticing that matter can be pure, a pure substance, or a mixture. It's not pure and impure, but rather pure and a mixture. In a pure substance, that substance only has one component. What does that mean? Uh, we will talk about it in a few seconds. On the other hand, a mixture is a combination of two or more pure substances in which each substance retains its own identity, not undergoing a chemical reaction. What does that mean? Hmm. Well, let's look at some examples of pure substances and mixtures, and then we will understand this better. So here is an example, or rather two different kinds of pure substances. They could be elements or compounds. And examples of elements are oxygen gas, hydrogen gas. Oxygen gas is one of a kind. Hydrogen gas is one of a kind. There is either hydrogen or nothing. There is oxygen or nothing. It's by itself. On the other hand, a compound is also a pure substance. Example of compounds are salt and water. If any of you knows what water is made up of, you know it's made up of something called H2O. Uh, what is H there? That's hydrogen. And what's O there? That's oxygen. So unlike an element, a compound is combination of elements. Similarly, salt, if anybody knows what's table salt made of, it's NaCl, which means there is sodium. Na means sodium and Cl for chlorine. They are also combined. Now, if these are pure substances, if compounds like sodium chloride, salt, and water are pure substances, then why does it say that a pure substance has only one component? And doesn't a mixture, isn't a mixture made up of more than two components? Yeah, well, here is the confusion that a mixture is made up of two components. It's rather two components mixed together where they do not undergo a chemical reaction. When we say water is a pure substance, it's because there is hydrogen and oxygen combined into each other. They have undergone a chemical reaction and now they are one. There is a one whole entity of hydrogen and oxygen, which we'll study later. Similarly, in salt as well, you have Na and Cl combining into each other. But in a mixture, you are just mixing them and they are not undergoing a chemical reaction. So that these are the two examples or two kinds of pure substances. An element, a pure substance that cannot be changed into a simpler form of matter by any chemical reaction because it's by itself. You cannot do anything else to hydrogen. It's hydrogen. On the other hand, a compound is a pure substance resulting from the combination of two or more elements in a definite reproducible way in a fixed ratio. In the case of water, the formula is H2O, two hydrogens and one oxygen combined to give you water. So these are the pure substances. Now I want you to type on Google search periodic table of the elements. Once again, it's periodic table of the elements. There, and once you do that, press enter and then do look at the images, and you will see uh, something known as the periodic table, and you will see how many elements are there within that table. All those elements make up the different kinds of pure substances, pure elements that we have. And when they are chemically combined into each other, you get compounds. And all, both of them together make up the pure substances. Now, what about mixtures? So these are the pure substances. What about mixtures? Do we have different kinds of mixtures? Well, yes, you see these two arrows here. We do have different kinds of mixtures as well. They are homogeneous mixtures and heterogeneous mixtures. Homogeneous mixtures are mixtures which have even composition. For example, when you buy milk from the supermarket, it says homogenized milk. What does that mean? It means that it's all even. Now, real milk that comes from the cow contains layers of fat and cream and such. And when you buy the milk from the supermarket, it doesn't seem to contain any of that because it has been homogenized. Every part of that milk is the same, whether you take a teaspoon from the top of the uh, gallon of milk or from the bottom. Other examples of homogeneous mixtures are air. In air, you have a specific amount of oxygen, nitrogen, and other gases, and they are all evenly spread out. You don't go to a portion where there is more oxygen and less nitrogen, or where there is more nitrogen and less oxygen. Everywhere it's even. On the other hand, in a heterogeneous mixture, you have different things mixed together but not evenly. When you mix oil and water, you will notice that they don't really mix. One portion is water, usually the bottom, and the top portion is oil. Even when you have very little oil and it's oil droplets within water, sometimes the droplets are large or sometimes they are small. If you have a mixture of salt and pepper, some portions may have more salt, other portions may have more pepper. Other examples are things like um, soil and pebbles. Some portions may have more pebbles, other more have more soil. So that's what a mixture is. That's what a heterogeneous mixture is rather. So a homogeneous mixture is uniform composition, particles well mixed, thoroughly intermingled. On the other hand, in a heterogeneous mixture, it's non-uniform composition and random placement.